Okay, hi everyone. These are from the Hardy-Weinberg actual questions and that, so the practice questions that are in your package and that. And again, we're taking a look at question number 1 here and that. So these are, again, only 2 ways to use these formulas. One is when they give you the frequency of the allele, and of course the other one is when they give you the frequency of the actual genotype. So let's do this first question here. We're going to go through the problem-solving strategies. So suppose in a fruit fly population, the frequency of the recessive allele for short wings is 0.30. Okay, so that's significant. So what we're going to do is we're going to underline that in our question when we're going through the problems, and we're going to start seeing what they've actually given us here. And I think that's probably, again, the hardest part of these questions is what are they giving you and what are they asking you to solve? So when we take a look at this, we say recessive allele. So when they say allele, we're going to just put in here, well, that's just single. That's just one single allele. Now, in our formula, we either have the dominant allele, which is again represented by P, or we have the recessive allele that's represented by Q. This one, they're telling us it's recessive. So we know they are giving us the Q value, not Q squared, but the Q, just the Q value itself, single Q. And we know that because it says allele here. So we're going to write that down just down here, transfer that information over here. Okay, so we got Q equals 0.3. Now what they're asking us is what is the expected 3 genotype frequencies in the next generation. So of course we have our formula. We know this, P squared plus 2PQ plus Q squared equals 1, or 100% of the population if we're using percentage. So what they're asking you is for these 3 different type of alleles. This, of course, being the homodom. This is different, P and Q, so this is going to be the heterogenotype. And Q squared is going to be the homorecessive. So those are the 3 genotypes that they're asking us to do. And all they've given us is the Q value. So once we have Q, we can see that in this formula, we also need to know what P is. So in all these questions, when they either give you the P or the Q, we have to calculate and find out what the other value is, or the variable is, so we can insert that into our formula. So we know that 1 minus Q is going to give us P. That we've done many times now, and you're going to do that in every type of question. So if we have Q, we're going to go 1 minus 0.3 equals P 0.7. Okay? And let's just put a box around that because, again, that is the key information that allows us to insert this information into the formula. Find the 3 genotypes. Very easy now. All we do is, again, this is the homodom. And we know it's the homodom because P represents the dominant allele. When there's 2 of them, that's the genotype, right, for the homodominant genotype. So if we take a look at that, we can see we have 0.7 times 0.7. Figure that out, we get 0.49. And let's go look at what they want the answer in. They want it in percentage. So we're just going to multiply that by 100 or move that decimal place over 3 times, 49%. Okay. Now for the 2PQ, we're just going to go 2 times 0.7 times 0.3. Okay, and when we do all of that, we come up with 0.42. These are very easy now. And again, the hardest part of this is just determining what they're giving us and what they're asking for us to solve. Once we know that, the steps are fairly similar, so they're not too bad after that. This one is 0.3 times 0.3. Again, that 2 means multiply it by itself. And so for that, we get 0.09. Multiply that by 100, move it over 2 places, 9%. Add up all those percentage, we do indeed get 100%. And those are the 3 frequency genotypes in a percentage. Okay, if you have any questions, just get a hold of me in email and we can kind of go through some of this. Okay, thanks guys.